Okay, so number 56, it says two numbers have a sum of 13. And if one number is y, then express the other number in terms of y. Now, in a section after next, so this is probably section 9.4, the whole section deals with word problems. So you're going to have to set up word problems, equations, set up equations using words to solve an equation, to solve that word problem. Here, though, you're just setting up expressions, so you're getting ready for that section. So 9.1, 9.2, you're going to see some words that you have to write as expressions, and that's going to be needed in section 9.4. The whole section deals with word problems in 9.4, and that's going to be on test 2. So you're going to have word problems to solve on test 2. All right, so let's look at 56. You have two numbers have a sum of 13. And it says if one number is y, then express the other number in terms of y. All right, so you have two numbers, right? And you know that when you add them up, what do you get? 13. So you can think of it this way. In your mind, you're thinking of number 1 plus number 2 has to equal what? 13. That's what you're told, correct? That's what you have in your mind. What are you told about one of the numbers, though? It's represented as y. Okay, so let's say this one right here is y, right here. All right? And then the question is, express the other number in terms of y. So express the other number in terms of y. So the other number meaning this number 2 that I have circled. That's the question. So you want to find out, well, in terms of y, what is this other number going to be equal to? What? I'm sorry, say that again? X. Oh, no. You're not going to use two different letters here. You're not going to start using two different letters until you get into college algebra. You can use the same letter because it said express it in terms of what? Y. So you want your answer to have y in it. Okay? All right, and all you do, remember how you solved an equation before. Let's suppose you had y plus 6 equal 8. All right? How'd you get y by itself? You subtract 6 from both sides, correct? Now, what if I said this? What if I said get 6 by itself? Get 6 by itself. What would you do? Subtract y from both sides, right? You would subtract y from both sides, and then you'd say, and then you combine like terms. And by the way, what property have I just used here? The addition property of equality. All right, now remember, one of your worksheets talks about properties, and knowing those properties, you need to know for your test 1. Okay, so that's addition property of equality. Once you use the addition property of equality, what's the next thing you have to do? Combine like terms. So y subtract y is what? 0. And so you get 6 equal, and then what is this? 8 minus y. All right? So that's the idea you want to use here. Now, technically, though, in the previous lesson, you solved for y, correct? But I'm asking you, because we're going to need this idea here, how do you get 6 by itself? Well, to get 6 by itself, you do what? Subtract y from both sides. So how do I get number 2 by itself? Subtract y from both sides. So I get minus y, minus y. What property have I just used here? The addition property of equality. Once you do the addition property of equality, what's the next step? Combine like terms. What's y minus y? And so this other number they're talking about, number 2, is now equal to what expression? 13 minus y. And so that's what they want, 13 minus y. So what's the other number equal to? 13 minus y. And it kind of makes sense. It kind of makes sense because what if I said this? 7 plus box equal 8. And let's say this was my y right here. That was my y. Okay? And if I say get box by itself, what is box equal to? 8 minus 7, which is the same thing as that y here. And then 7 plus 1 equals what? 8. All right, so that's the idea there. So in your mind, you're given that those two numbers have to be 13. So if one of them is y, then the other one has to be 13 what? Minus y. Okay?
What would you like us to put in that, like the number 2 slot? Just number 2? Or
I'm sorry, what are you talking about, number 2?
Like,
Oh, here? Oh, no. Okay, so that's what you would think of in your mind, okay? So in number 56, when you actually, on the worksheet or a test, when it has those words and it just says express the other number in terms of y, you just put the answer in the blank. What's going to be the answer in the blank? What's the other number? 13 minus y. That's what you put in the blank. Okay? So this is just your mind. You don't have to show this. That's what you have in your mind, though. So if two numbers add up to be 13, and one of them saying is y, then the other one has to be 13 minus y. Okay? So that would be what you would put in the blank, 13 minus y. Okay, so then number 58. 58, you have...
Excuse me. Where do you get all these other numbers from on the side? Don't you just plug in
Well,
the number?
No, I'm just making that up to help us to talk
okay.
about this.
I was, like,
No, I made that up. I said, suppose 7 plus 6 equal 8. And in the previous lesson, I said to solve for y, you subtract 6.
Yeah, I was writing on the date.
Okay, and then I said, well, what if I said solve for 6? Then you would have to subtract y. So if I say solve for number 2, then you have to subtract y.
Gotcha.
Okay?
All
right. 58, it says that a 5-foot piece of string is cut into 2 pieces. So in section 9.4, you're going to see that in a word problem, and you're going to have to solve for those 2 pieces. But here, they just want you to write an expression. So you have this board, or a string, whatever it is. It's a string, and it's cut into 2 pieces. All right, so I'm going to cut into 2 pieces. And it says this, if one piece is x feet, so they're saying this one right here is x feet, okay? And express the other length in terms of x. All right, express the other length in terms of x. Now, do you understand that the other length they're referring to is this right here, right? So that's the question. So they want to know that other piece here, right here, what is that going to equal in terms of x? In terms of x. So the way you set it up is going to be important, because when we do 9.4, you're going to have to set up an equation. So what do you think? 5 minus x. 5 minus x is correct. So if those 2 pieces, what does that 5 right here represent? The length of both pieces, right? So it's kind of like number 1 plus number 2. So what if I said piece number 1 plus piece number 2, that has to equal what number? 5. And they're telling you that one of the pieces has what length? X. So let's say it's this one. And they want to know, so that other piece, this right here, you see this right here? That other piece, what is that going to equal in terms of x? So you got to get that other piece by itself. So use the addition property of equality. So if I'm going to get piece number 2 by itself, then that means I get rid of that x. How to get rid of that x? Subtract x from both sides. And once you use the addition property of equality, what's the next step? Combine like terms. And so you get piece number 2 equals what? 5 minus x. And you can't combine those, right? Don't say that's 5x. 5 minus x is not 5x. You cannot combine those two. Those two are not like terms. So you leave it as 5 minus x. And so in the blank, you would say 5 minus x. That's the other piece. So the other piece is 5 minus x. All right. Number 60. Okay, number 60. Okay, 60, it says that recall that 2 angles are complementary. Now, there in geometry, high school geometry, you talked about supplementary angles, you talked about complementary angles. Supplementary angles are 2 angles whose sum add up to be 180, good. Complementary angles are 2 angles whose sum is equal to 90, okay? Now, that's something you don't have to remember. I would have told you those definitions for that. Now, so you have 2 angles, and they draw the diagram for you. You see where they draw it for you? So two angles, they're telling you that one of these angles is x degrees, right? And they want to know what is that other one equal to. That's the question. So what's the other one? All right, what do you think?
90 minus x.
90 minus x. Y'all agree? Because look, let's call this angle 1 and this angle 2. The measure of angle 1 plus the measure of angle 2 has to equal what? 90. So if the measure of angle 1 is x, see this is x, then how do I get the measure of angle 2? Subtract x from both sides. And then combine like terms, and so I get the measure of angle 2 equals 90 minus x. And that's what you put in the blank, 90 minus x. All right. 62. All right, 62. You have, okay, so the longest interstate highway in the U.S. is I-90, which connects Seattle, Washington, and Boston. The second longest interstate is I-80, connecting San Francisco and Teaneck, New Jersey. And it's 120 miles shorter than the I-90. All right? And so it says this, if the length of I-80 is m miles, express the length of I-90 as an algebraic expression in terms of m. All right, so now that one's going to be, it's not as easy as the other three. So you're told that the second longest interstate, I'm on sentence number 2, the second longest interstate, I-80, so you're told I-80 is 120 miles shorter than I-90. So I-80 is 100, let me put this, is,
So I-80 is going to be
okay, so I-80 is 121 miles shorter than I-90, correct? Okay, so which one's longer, I-90 or I-80? I-90. I-90 is longer. Okay, but they want to know this. They want to know if the length of I-80 is m, so you're told that this length right here is m, okay? The length of I-80 is m. They want to know, express the length of I-90, so I'm put a little question mark here, express the length of I-90 in terms of m, in terms of m. Okay. She said I-90 is m plus what? 121. It kind of makes sense because I-90 is longer than what? I-80. Okay, so yes, I-90 would be, the length of I-90 is equal to, I'm just putting equal to m plus 121. Okay, so the length of I-90 is m plus 121. Because I-90 is longer than 180 by how many miles? 180. Now, in the problem it says use the word shorter, but that's just to indicate that I-80 is shorter than what? I-90. So if you want to get I-90 by itself, you have to use the fact that I-90 is 120 miles longer than what? I-80. Okay? All right, so that will be the answer you put in the blank, m plus 121. All right, 64. 64. Okay, so 64 you have the largest meteorite in the world is Hoba West, located in whatever that word is. Okay, it weighs, its weight is 3 times the weight of the, you think they could put words that we can pronounce, Almaty meteorite located in outer Mongolia. If the weight of the Almaty meteorite is y kilometers, express the weight of the Hoba West meteorite as an algebraic expression in y. Okay, so let's read this again. So when it says that second sentence, when it says its weight, what is it referring to when it says its weight? Which meteorite? The one in Hoba West? Okay, so let's just say this. Hoba West meteorite, and it says that its weight, so Hoba West meteorite, its weight is 3 times the weight of a Monte meteorite, right? Its weight is 3, hold on, let's see, 3 times the weight of a Monte, correct? All right, and it says this, if the weight of our Monte is what? Y, so this right here is represented as Y, correct? And they want to know, then what is the weight of Hoba West? What is the weight of Hoba West in terms of Y? Y times 3, but we don't say Y times, in your mind you're saying Y times 3, but how do we write it? What's the best way to write this? 3Y. Always put the coefficient first. So the answer is going to be 3Y. Okay? So 3Y. All right. And so that was those problems. So the ones on my math lab are very similar. I haven't put a worksheet on this yet. It's that part's not in your test anyway. If you look at your study guide, it's only on the worksheets that I gave you today or class period. But this will be needed for section 9.4. And we're going to do 9.4 starting probably Thursday of next week. Oh, your test is next week. So either Tuesday, end of Tuesday of next week, or the beginning of the week after. Okay? But your test is Thursday. Your test is Thursday. Okay, now let's look at the back page. Go to the back page. Okay, so the back page is from page 641. So that's section 9.2. And it's on page 641. Okay, so when we get to 9.4, when we get into those word problems in 9.4, you're going to see the word consecutive integers quite often in some of these problems. So you'll see consecutive integers, you'll see consecutive even integers, you'll see consecutive odd integers. So let's kind of talk about what we mean by consecutive integers. Well, first of all, what are integers? Give me some numbers that you think are integers. 3 is an integer.
-1/2.
-1/2 is not an integer.
It's a whole number.
It's a whole number or it's negative, right? Those are integers. So your integers are things like 0, 1, 2, 3, 4, 5, and so on. And it's what? Very good. I'm glad you used the word opposite. That's what I want you to use. And it's opposite. -1, -2, -3, -4, and so on. So how many integers are there? I didn't want you to use that word. I want you to use another word that you learned before.
What did you say?
Huh? An infinite number. There's an infinite number of integers, so meaning you cannot count them. All right, you cannot count them. All right, so that's an infinite number. All right, so those are integers. So when you talk about consecutive integers, so if my first integer is 9, what's the next consecutive integer? 10. What's the next consecutive integer? 11, and so on. Okay? Let me put this as an example. If my other one is, let's say, 121, what's my next consecutive integer? 122, and so on, right? What about -6? And let's increase it. So -6, what's the next higher one? -5. So remember on the number line, the closer So here's 0, here's -1, -2, -3, and so on, correct? So your numbers increase in size as you go from left to right. So -6 is smaller than -5. So -6, -5, what's the next higher one? -4, and so on. Okay? All right, so those are examples of consecutive integers. All right, let's talk about consecutive odd integers. All right, some examples would be like 9. What's the next one? 11. What's the next one? And so on. So those are consecutive odd integers. Is 11 and 15 consecutive odd integers? No. They're not adjacent to each other. If you start with 11, what's the next number that you need to say? 13. So the answer is no. So those are not consecutive odd integers. And again, if you, let's say 21 will be the next one. 23? Okay. Now, could you have, let's suppose I start with 21. Could someone have said the next consecutive integer or a consecutive integer would be 19? Yeah, you could have done that. Just as long as they're consecutive. Okay?
Say negative, they couldn't say 17 though, correct?
Say it again?
They couldn't say 17 though, correct?
If I start with 21, your next one is not 17 because they're not adjacent to each other. You're missing that 19.
Mm-hmm.
And then consecutive even. Our consecutive even integers. So if the first one, let's say is 10, then what's the next larger one? 12. You all agree? If we keep on going, there'll be 14 and so on. All right, so any question what consecutive means? Okay. Now, when we get to that section 9.4, you got to remember these ideas. What do you mean by consecutive integers? What do we mean by consecutive odd integers? What do we mean by consecutive even integers? Okay, so that's going to come back in a couple of more sections. All right, so let's look at number 78. 78. Okay, 78 says this. If x is the first of 3 consecutive even integers, if x is the first of 3 consecutive even integers, then write their sum as an algebraic expression. Write their sum as an algebraic expression. All right, now let's think about this. So you're dealing with how many integers? 3, and they're consecutive what? Even. Consecutive even. And it says x is representing which one? The first. Okay, so look, you have first integer. And so we get into that section, that's how you're going to write this. You're going to say first integer, second integer, and third integer, right? Now you could be a little bit more specific. You could say the first even integer, the second even integer, the third even integer. You could be a little bit more specific with that. But you're dealing with integers. They're telling you, though, that the first one, you're going to let that be what? X. You let that be x. Okay? So if my first one is x, how do you think you're going to represent the second one? 2x? All right? So someone said 2x, right? So let's think about that. Someone said this. I'm just writing what someone said now. Okay. So if my first one is, we're making this up, if my first one is 6, if this is 6 right here, then the next one better be what? 8. What's 2 times 6? So is 2x correct? No, 2x is not correct. The next one has to be what? 8, correct? If that first one's 6? So if my first one's 6, what do I need to do to 6 to get 8? Add 2. Add 2. So if my first one, let's say, is 12, what's going to be my next one? 14. What do I need to do to 12 to get 14? Add 2. So 12 plus 2, right? 6 plus 2. Well, but my first one, I don't know what it is. It's represented as what? X. So what is going to be the expression for the second one then? X plus 2. Very good. X plus 2. Now, x plus 2 is not 2x because they're not like terms. So don't say that's 2 times x. X plus 2 is not the same as 2 times x. All right, now let's talk about the third one then. If my first one's x, how do I get that third one?
X plus 4.
X plus 4. X plus 4. So, and all you got to do to help yourself is pick a number for x. So let's say my number is 6. Then the next one is going to be 8, right? That's x plus 2. Then the next one is going to be 10. That's 6 plus what is 10? 4. So if my first one's x, I'm going to say x plus what? 4. So my third one is x plus 4. All right. So you found your expressions for each of those integers. So my first one is x. My second one is x plus 2. And my third one is x plus 4. Okay? Now, here's what they want you to do, though. They want you to do what with those three expressions? But what word? Yeah, but what word, though? What's a key word there as well? The sum. The sum. They're telling you that you're going to do what to those three things? You're going to add them up. All right, so their sum will equal x. So I'm going to just write this. The first integer plus the second integer, right? Plus the third integer. That's what they're telling you they want. They want you to find the sum. Well, what is the first integer represented as? What's the second integer represented as?
X plus 2.
And what's the third integer represented as? X plus 4. And so all they want you to do now is to combine like terms. So what's the answer?
X plus parentheses, x plus 2 parentheses plus
3x plus
parentheses.
6.
Okay, so what she's doing is just putting those in parentheses. Did you have to put those in parentheses? No. So what's the answer, though? You got to combine like terms. What's the answer? 3x plus 6. That's the answer. All right, 3x plus 6. All right, number 80. Okay, number 80. All right, this time you're dealing with two consecutive integers. Not odd, not even, but just what? Consecutive. They're just consecutive integers. Okay? So it says this. If x is the first of two consecutive integers, express the sum of 20, and the second consecutive integer as an algebraic expression containing the variable x. All right. So you're dealing with how many integers? 2. So just like we did this, you're going to say first integer and what? Second integer. And that's it, right? Because you're only dealing with 2 of them. So say first integer and then second integer. They're telling where the first is. And you're going to use that idea in section 9.4. You're going to normally what you're going to do is let the first one be x or be your variable. So this is going to equal what? X. All right, now let's use that same idea we did number 78. How do I write the second one then? X plus what? 1. Good. Because if my first one is 6, then my next one has to be what? 7. So I get 7 by saying 6 plus 1. So then this will be x plus what? 1.
It'll be 19.
Oh, hold on. All right. Okay, now this is what they're telling you. They're telling you that the sum of those two is what? 20. The sum of those two is 20. So then the question is this. Oh, no, I'm sorry. They're not saying the sum is 20. Read it again. They're saying that express the sum of 20 and the second. Okay, so yeah, you got to be careful. It didn't say that they add up to be what? 20. It doesn't say that. It says express the sum of 20 and what integer? The second. And what's the second? X plus 1. And then what's that equal to? X plus what? 21. That's the answer. X plus 21. All right, so it says express the sum of 20 in the second integer, and you get x plus 21. 82. 82. All right, now look at 82. Okay, so you have this quadrilateral. And remember, a quadrilateral has how many sides? 4. All right, so it has 4 sides. And it says 2 sides of this quadrilateral have the same length. And they're representing those 2 sides as x. So if you look at the diagram, they're saying this is x and this is x. Okay? And then it says the other 2 sides also have the same length. But you're not told what it is. All you're told is that these 2 sides is x. They're represented as x. But you're told this next. You're told that these other 2 sides, which have the same length, are the next consecutive odd integer. So these sides right here, this side and this side, are represented as 2 consecutive odd integers. So if this side is x right here, then how would you represent that other side that I'm pointing to? X plus 2? Is that correct?
I guess it depends on if it's an odd number or if it's an even number.
No, but it tells you it has to be what kind of number? Odd. And she said, I guess it depends on whether it's an even or an odd number. Well, you're talking about what kind of numbers? It has to be an odd number. So my first one is 9. If this is 9, then this has to be what? 11. And how do we get 11 from 9? 9 plus 2. So do you see that whether you're talking about consecutive even, right here, or consecutive odd, it's always going to be x plus what? 2 is the next one. Okay? Now some students get confused and they want to say x plus 3. You got to be careful because if this is 9, what's 9 plus 3? 12. That's not even the next consecutive odd number. Okay? So this is x, then this has to be x plus 2. Because you're told that this other side is represented as the next consecutive odd integer. And now it says this. Write the sum of all those sides. Okay? So what do you think you're going to do? Add them all up. How many sides are there? 4. Now, you do see in the diagram or in the problem where they're telling you that these opposite sides are the same length. So if this right here is x plus 2, then this has to also be what? X plus 2. And all they want you to do then is to add up those 4 sides. So I'm going to start with the one that's circled. I'm going to go counterclockwise. So x plus, and then what do I write here? X plus 2 plus, and then x plus, and then what? X plus 2. But that's not the answer, because what do you have to do next? Combine like terms. So what's the answer? 4x plus 4. Okay? 4x plus 4. All right. So again, when you're talking about consecutive odd or consecutive even, if regardless of which one you're dealing with, if x is your first, then the next one has to be x plus what? 2. Okay? Because even if it's even or odd, if it's 6, 6 plus 2 is going to give you 8. If it's 5, 5 plus 2 is going to give you what? 7. So always remember, that's always going to be x plus 2 all the time. Okay, so that should be enough for, that's all the even problems there. That should be enough for my math lab. So I'm going to assign my math lab. All right, now when you do these problems on my math lab, make sure you have this in front of you. It's very similar to that. And I think you have like 3 tries or 4 tries on that one, on my math lab. Okay? All right, now let's continue talking about solving equations. All right, solving equations. And so for the most part, this is 9.3, section 9.3, but most of it is a review, probably about 70% of it is a review from the previous two sections that we did. So, for example, let's look at this. Okay, this is section 9.3 on page 647. So this is number 2. So even though I'm writing number 2, and number 2 is in section 9.3, and 9.3 is not in your test, number 2 could still be in your test because it's very similar to what we did. Okay, watch. Negative 3x plus 1 equals negative 2 times 4x plus 2. So you're going to solve this equation. Think back what we talked about last class period. What's the first thing you're going to do? Parentheses. What property is that? Distributive property. We talked about that last class period, and that was section 9.2. So a lot of this is a review from the previous lesson. So first step to do is to use the distributive property. So I'm going to get negative 3x plus 1 equal, now what's going to be on the other side? Minus 4. And again, what did I just use? Distributive property. Now, remember what we did last time. Once we did distributive property, what is it that sometimes we could do next? Combine like terms. Can I combine like terms on either side? No. All right. Then notice I have variable on both sides, constant on both sides. It does not matter which one you deal with first. Let's deal with the variables first. And it does not matter whether we bring the variables to the left or the right. Remember that? Okay? It's up to you which side you bring it on. It does not matter. So you got to tell me which side you want to bring the variables on. You want to bring the variables on the left, or you want to bring them on the right? To the left? Okay. All right. Now, what property am I going to use next based on what we talked about last class period? The addition property of equality. So that means I need to get rid of this negative 8x. So is adding 8x or subtracting 8x going to help me? Very good, adding 8x. And remember how we did this? We aligned our like terms. We aligned our like terms because the next step is to do what? Combine. All right, so very good. A lot of you remember what we did last class period. So the property that allowed me to add 9x was the addition property of equality. Now remember, we talked about this also, that whenever you use the addition property of equality, the next step is to do what? Combine like terms. And so what's a negative 3x and a positive 9x? No, not 5. Oh, I'm sorry. You're right, 8. Okay. Yes, it is 5x, right? 5x. So negative 3x and positive 8x is 5x. Plus what? 1 equal. And what happens over here? Yeah, so that's 0. 0 and negative 4 is a negative 4. So that's where we're at. Okay? And again, now remember, all these equations I'm writing are equivalent. And remember, equivalent equations are equations that have the same solution. So when I get that x equal number is going to be a solution to each of those equations. All right, so they're all equivalent. Now, what allowed me to go from here to here is to combine like terms. That's how I got this, combine like terms. Now, remember, the whole idea is to get x equal a number, correct?
Right.
All right, I'm not at that point yet because I still need to get that 5x by itself. Now, remember, always do the multiplication property of equality last. So see right here how I'm multiplying x by 5? What's the opposite of multiplying by 5? Divide by 5, right? But you're always going to do that when? Last, at the end. So you want to continue using the addition property of equality. So how do I get rid of that plus 1? Subtract 1. So again, that's still what property? Addition property of equality. And then once you do the addition property of equality, what's the next step? Combine like terms. So notice they alternate like this. And so when I combine like terms, a positive 1 and negative 1 is 0. So what's left on the left? And what's going to the right? Negative 5. And then one more step and you're basically done. So how do I get x by itself? Divide by 5. So remember, right now, multiplying by 5, the opposite of multiplying by 5 is to do what? Divide by 5. Because remember, you always want to get this coefficient to be what number right here? 1. And it is, because 5 divided by itself is what? 1. 1 times x is x. And what's the negative 5 divided by positive 5? Negative 1. So there's your solution. So again, when I divided by 5, that was a multiplication property of equality. Now, once you do the multiplication property of equality, the next step is to simplify. So, and I simplified by doing this. 5 divided by 5 is what? 1. A negative 5 divided by positive 5 is a negative 1. So that's simplifying. And that's it. So x equal negative 1 is your solution. So it's a solution to each of these, but in particular, it's a solution to the original, because that's what I wanted to solve. So all these are equivalent equations, so they all have that same solution, negative 1. All right. So again, although this is section 9.3, you could see this on your test because that's from 9.2. And notice how we did this. That was in your last class period. So if you look at the notes, you'll see it looking like this. And I think if you look at your study guide, there's on part C, there's like 2 problems from part C 9.2. And it looks like this. So just make sure you can do this on your test. All right, so even though this says 9.3, I would make a little star here for number 2 because that could be on your test. And notice the little steps. There's your steps. Okay? All right, so let's look at number 6. Number 6. So number 6, let's suppose we had, well, this is what number 6 looks like. Okay, that's number 6. Yeah, that's 5x minus 10. All right, what are you going to do? Okay, so you would get rid of the parentheses. What number is understood to be in front of that parentheses?
1.
A negative 1. So if you need to put that negative 1, you put the negative 1. So then the first step then would be to use the distributive property. So what does that become?
Negative 5x plus 10 equals 5.
Okay, so that's what you get, right? All right, so to get to that point, I use the distributive property. Then the next step, remember, usually, not always, the next step is to combine like terms, but can I combine like terms on either side? No. All right, so then the next step is to use the addition property of equality. Now, look, in the previous problem, you saw you had variables on both sides, constants on both sides. And so how many times did I use the addition property of equality? Twice. Here, though, I don't have constants on both sides. I just have the constant located where? On which side? The left. So then what that means to me is that it is easier if I bring the variables to which side? To the right side. Now you could bring the variables to the left, but then you have to do an extra step. Okay? And I'll show you what I'm talking about, but just be careful in either way. So since the constant only appears on one side, leave it there. So let's get rid of that negative 5x that's here. So that's the addition property of equality. So am I going to add or subtract? You're going to add 5x. So add 5x to both sides. And notice I'm aligning my like terms. And you see how it's going to look, right? You're going to say plus 5x plus 5x. Make sure you do that. You want to get as many points as you can on that test. So there's the addition property of equality. Then once you do the addition property of equality, what's the next step? Combine like terms. Okay, so what's negative 5x plus 5x? 0 plus 10 is 10. What's 5x plus 5x? All right, so that's where I'm at. So I was combine like terms. That's how I got this. Combine like terms. One more step and you're done. How do I get x by itself? Divide both sides by 10. Divide both sides by 10, just like this. Make sure you show it. Say divide by 10, divide by 10. Now, that was the multiplication property of equality. And then once you do the multiplication property of equality, the next step is to simplify what you see. So what's 10 divided by 10? So 1 times x is x, and what's 10 divided by 10? 1. So there's your solution. So your solution is x equal 1. Right. Now, I just want you to remind you about this. So, that part here, I'm just going to rewrite this over. So I'm going to put this as 6 star. So the part where we had right here, negative 5x plus 10 equal 5x. So remember what we did was we brought the variables to the right side. Remember that? Some of you could have brought the variables to the left. It does not matter. If I do that, then that means you want to get rid of this 5x that's on the right side. So if I use the addition property of equality, are you going to add or subtract 5x? Subtract 5x. So I'm going to line my like terms, just like that. So that was the addition property of equality. Then once you do the addition property of equality, next step is to combine like terms. What's a negative 5x and a negative 5x? Negative 10x. Plus what? 10. Equal, though, 0. You have to put that 0 there. Okay, a 5x and a negative 5x is 0. All right, now you got to get x by itself, the term x by itself. So that means you want to continue doing the addition property of equality. So you want to get rid of that plus 10. So what's the opposite of adding 10? Subtract 10. So that's the addition property of equality. Then once you do the addition property of equality, the next step is to combine like terms. So when I combine like terms on the left side, what happens to the 10 and negative 10? Okay, 0, because they're opposites. And the only thing left is what term? Negative 10x equal. And what's 0 and a negative 10? Okay. And now what's the next step? How do you get x by itself? No, not add 10. No, okay, you did that in the same thing when you came up early beginning of class. She said, now let me ask you this. Okay, she said this. And some of you are going to do this. So in your test, some of you are going to say this. You're going to say divide by 10, divide by 10. Okay? Now, I can divide by 10 on both sides, right? There's nothing wrong with that. Mathematically, it's correct. But don't say the answer is negative 1. Okay? The answer is not negative 1. Because this right here is not a 1. It's a negative 1. Now, she said divide by 10. The best thing you should have done was divide by a what? Negative 10. Divide by the coefficient. And I think what confuses some of you is I say this, which is correct. I'd say, what's the opposite of multiplying by negative 10? And so when you hear the word opposite, you think of the opposite of a number. That's not what I'm asking. What's the opposite of multiplication? Division. That's what I'm referring to. Now, let me go ahead and finish this right here, because some of you are going to do this. If you do this, then you better say that this right here is what kind of 1? Negative. You better have that written down. Okay? And a negative 1 times x is a negative 1x, right? Or negative x. Equal, what's negative 10 divided by 10? But then you see you went into a circle here, because you still hadn't gotten x by itself. So what's the next thing you got to do? Divide by negative 1, which you should have done earlier. You just went into a circle. So negative 1 divided by negative 1 is a 1. 1 times x is x. And what's negative 1 divided by negative 1? 1. The best thing you should have done is right off the bat divide by what? Negative 10. Because a negative 10 divided by itself is what? Is 1. 1 times x is x. And then what's negative 10 divided by negative 10? 1. All right? So you got to remember that when you get to that last step where you're using the multiplication property of equality. What?
Our class is going to be over.
I'm so sorry.
All right. I hate to see what she does when the time changes. All right. Okay. So when you get to that part where you have to use the multiplication property of equality, always divide by the coefficient of x, and that saves you some steps. You don't go through that circle that we did here. All right. Let's look at number 12. Number 12.
Thank you for clearing it up for me too, because I've been doing that a lot on my paper.
No, that's fine. Yeah, there's nothing wrong with that. It's just that you're making it a little bit more challenging for yourself.
A little more leafly.
All right. So your variable is b. That's a b. It looks like a 6, but it's a b. So that's 5 minus 6 times 2 plus b equals b minus 14. Now again, that could be on your test. Even though section 9.3, that we talked about in 9.2, last class period. So what's the first thing you're going to do? Get rid of the parentheses, distributive property. What are you going to multiply everything inside the parentheses by, though?
-6.
-6. Okay, -6. So what some people do is they have a habit of wanting to say 5 minus 6 is a -1. You don't do subtraction. Because remember, right here you're saying 5 subtract 6 times, right? And according to your order of operations, I multiply before I do what? Subtract. So you have to do the multiplication first. All right, so distributive property. So you're going to say 5, and then what's going to be the rest you're going to write?
-12 minus 16.
Very good. And on the other side, that's b minus 14. All right, so that was distributive property. Okay, now the next step is to combine like terms. So when I combine like terms on the left, let's put the b's first. So put the b first. That'll be if
-16
-6b, and then what are these constants?
-7.
-7 equal b minus 14, right? Okay, and so let's combine like terms. All right, so notice I have variables on both sides, constants on both sides. Let's deal with the variables first. You want to bring the variables to the left or the right? It does not matter. What do you want to bring them on? To the left? Okay, so if you want to bring them to the left, that means you want to get rid of this b right here. So subtract b from both sides. And make sure you say subtract b, right? So you want to get as many points as you can. So don't be lazy and skip steps here. You have time to do this. Don't be lazy. You'll be upset. So subtract b. Align your like terms, because the next step is to do what to those terms? Combine them. So what allowed me to subtract b from each side is the addition property of equality. So what you do to one side, you do to the other, correct? That's what that means. So if I add or subtract something from one side, I got to do it to the other side. Now the next step, once you do the addition property of equality, the next step is to combine like terms. So what's a -6b and a negative b?
-7.
Okay, good. -7 equal
14.
-14. B minus b is 0. Now be careful. Make sure you see that term here, that constant is not a 14, but a -14. So that's where I'm at. Then remember at the previous step, I brought the variables to one side. Now I'm going to bring the constants to the other side. So that means you want to get rid of which term, which constant? -7. So when I use the addition property of equality, how are you going to get rid of that -7? Add what? 7 to both sides. So the addition property of equality. Okay? And then once I do the addition property of equality, the next step is to combine like terms. So when I combine like terms, a -7 and a +7 is 0. They're opposites. So when I add terms that are opposites, I get 0. But what's left? Okay, what's a -14 and a +7?
-7.
All right. Now, what property am I going to use next? But that is not called the division property. Although we are dividing, it's actually called which property? Multiplication property of equality. So you're going to look at the coefficient of b. What's a coefficient?
-7.
So right now I'm multiplying b by -7. The opposite of multiplication is division. So I'm going to divide by what?
-7.
-7. So there's a multiplication property of equality. And now you're going to simplify. A -7 divided by -7 is a 1. 1 times b is b. A -7 divided by -7 is a 1. So there's your solution. Okay? All right? Okay, now, next class period. Let me just tell you where we're headed with this. Okay, so remember we on one of the problems we did last class period, actually several, there were fractions. And someone said, let's clear the fractions. And we said, well, we hadn't got to that point yet, so we did it a different way because the denominators are the same. The next section, now we're going to get to where the denominators are different. So in that case, you do want to clear the fractions by multiplying both sides by the LCD. So that's where we're headed next. Now, let me say this, though. All these problems that we did here, you could see on your test, because that was from the previous section. When we clear the fractions, that's going to be on test 2. So that'll be Tuesday. That'll be test 2. Okay, so